Hi, this is Tom again, and I want to continue on the theme of these models of tax smoothing. And we'll do a little review to begin with, and then I'll turn to sketch the Lucas-Stokey model of 1983 and point you to a quant econ lecture. Okay, so I'm going to review from last time. We basically had a model in the spirit of Barrow. So we had incomplete markets. And we had an R beta equals 1 story where we made this up. We had this up exogenous in the spirit of Milton Friedman, permanent income model, and Robert Hall's version of it. So R is equal to beta inverse, and that was hardwired in. And then we wrote Barrow's version of a government budget constraint, which we wrote like this, just to remind you. We wrote that version. And then we ended up making some assumptions. We had GT, we had that was Markov. So we have some XT as some Markov state. That's going to be first order Markov. And we had a couple versions of that. Discrete space, finite state, or continuous state. And then here's what I want to emphasize now. We had a measurability assumption. So we said what BT was risk-free 1 period government debt falling due at the beginning of T, period T, but incurred during that period T minus 1. And similarly, BT plus 1, that's going to be blah, 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 blah. It's become due at beginning of T plus 1, but incurred at period T. So I'm going to be pedantic here. The content of this is BT is going to be measurable with respect to, meaning it's going to be a smooth function of, with respect to, not XT, but X superscript T equals, X superscript T minus 1 equals X T minus 1, X T minus 2, all the way back to some, depending on where we're going to start things. So what I want to stress is in incomplete markets setting, what it means for something to be risk-free is a measurability assumption like this. So what's going to happen is the heart of this incomplete markets model that we made up in the spirit of Barrow is the government budget constraint's going to be like this. G, we could think of, at the end of the day, we can think of G is going to be a function of a Markov state. So G itself, on some smoothness assumptions, is going to be Markov. It's going to be a smooth function of Markov state. But B, I'll write it T minus 1, if you will, is going to be a function of X T minus 1. And then it's going to happen that taxes, I'll write T, is going to be a function of xt minus 1, that history. And then we're going to have plus beta b, and that's going to be a function at t. It's going to be a function, well, not a, it's going to be a, it's then going to be end up being a function of the entire history. Okay, so notice the measurability that I built in here. That's the heart of the model of Barrow. It's measurability and history dependence. And you know what we saw was our version of tax smoothing was, it actually turned out in the Barrow's model, this TT is actually going to be a random walk, just like Hall got it a random walk. And government debt is going to have a unit root. It's actually going to be co-integrated with taxes. If you want to read more about this, there's several places. It's, you know, in effect, using the isomorphism that we have. This is covered in the second chapter of Lundquist-Sargent, this co-integration. And actually, Sidney Ludvigson's done a lot of work in the consumption dividend space that exploits this same structure. Okay, so that's the Barrow model. Okay, now let's go to the our baby's version of the Lucas-Stokey model. Well, so there we had, and what I want you to stress is the different measurability assumption. Again, what did we do when we did Lucas-Stokey? Well, we had state contingent debt. I'm going to be very pointy headed here. State contingent debt, which means we're going to have one period arrow securities. And we're going to have a full array of them. So what the government budget constraint is going to look like, well, I'll copy it down. It's now going to look like G, you know, I'll start writing GT plus B, again, T. So it's going to look kind of just the same. It's going to be TT. I'll add some stuff. And now what I wrote was, what did this mean? I stuck as close as I could to Barrow. I'm going to put this integral bt plus 1 of xt plus 1. And then it's going to be dp of xt plus 1 given xt. And the spirit of this is there's going to be a Arrow-Debreu pricing kernel. I'm sorry, an Arrow one period securities price kernel, which is, I made this up. Made up that kernel. So okay, so another way to write this is we're going to have G of xt, and look at the measurability. B is going to be measurable with respect to xt, not xt minus 1. And then we're going to have t, well, the consequence, this is going to be an outcome. An outcome is t is going to be a function of the Markov state only. So we're going to kill the history dependence. The history dependence that came through in Barrow's model is going to be, it's going to vanish in the baby's version of Lucas-Stokey's model. And then we can write this as beta, and I can write this as E of B of xt plus 1 conditioned on xt. So this is going to be our baby's version of Lucas-Stokey, and the where I make this up, just as we emphasized last time. And now what's going to happen is it's going to be quite different. Tax collections are not going to be a random walk. They're actually going to be an exact function of the Markov state. And in particular, they're going to be actually, they're going to be, if the Markov state is government expenditures itself, which it is in many examples, taxes will be a smooth function of GT only. So the smoothness, it's a play on words. If taxes aren't going to be very volatile, it'll be that the slope. It's the volatility is all going to be about the slope. So the time series behavior of the optimal taxes in these two settings are quite different. And remember, I told you this story that maybe you shouldn't, no particular reason you'd be interested in, was that when Barrow gave his talk at the University of Chicago, on his paper, 79 paper, which is hard to read, as Barrow talks about, it's a brilliant paper, but it's a little hard to read because there's lots of things that are implicit there. He talks about random walks, but the random environment really isn't fully laid out. And I could see Lucas wasn't pleased. I remember during the talk, he said, I want to see the environment so I can actually see what problem you're solving explicitly. And I want to see all the randomness laid out. And when Lucas and Stokey laid it out, they got a very different outcome. They didn't get taxes being a random walk, in the sense in which they got, and government debt behaved quite differently. So that's my introduction. So now what we're going to do, I'm going to transition to show you a version of Lucas-Stokey, 1983. And I'm going to put the baby back in the bathwater. And that's the key thing, is Lucas and Stokey are not going to assume that this is equal to this. They're not going to assume that, which I made up to make things easy. That's my baby's version. No insult to babies, because this has the virtue of showing a significant fraction of what's going on in the Lucas-Stokey model, but not the part that they emphasized. They're going to make Q, they're going to put a closed economy, and they're going to relate Q. The argument's going to be like this. Q is going to be related to, well, beta U prime CT plus 1 U prime CT times some probability. It's going to be more like this. And now it's, and I'm being loose here. It's going to be like, there's going to be a version of chapter 8 is going to be that at one period error security prices are going to be linked to behavior of consumption. But when the government changes a tax, and now the tax is going to be modeled more completely, it's going to be a tax rate, and it's going to be a distorting tax. When the government changes tax rates, it's going to change the pattern of consumption, and it's going to change these error security prices. But now, essentially, that means it's going to change the price of government debt. So the government's going to be issuing debt that it partially determines the price of. So the government's going to manipulate prices in such a way as to maximize our welfare criterion. So that's where we're going to go. And that's going to unleash forces that I completely shut down when I adopted this. So it's a classic analysis, and I want to show you a little bit of the structure of it. And try to convince you that it's worth studying. That's where I'm going to go. So here's where I'm going to hopefully try to persuade you that this is model is worth studying in detail, partly because it opens a structure to a really significant literature, and it's worthy in its own right. So I'm going to base this on this QuantiCon lecture. So there's Python programs for everything we do. So table of contents shows kind of what's going to be going on. Lucas and Stokey are going to start by laying out a competitive equilibrium of distorting taxes and lay this out. And you can imagine this, there's going to be actually a manifold of competitive equilibria. And this manifold of competitive equilibria is going to be indexed by a, you could think of it as a manifold of budget feasible government policies that involve choosing distorting taxes and government debt. So there's going to be a whole manifold, a set. And now that's just a competitive equilibrium. Now the Ramsey planner is going to have the interest of it's going to be a representative consumer. Ramsey planner has the interest of the representative consumer at heart. And its job is it looks out and it says, well, there's all these competitive equilibria. The welfare theorems aren't going to hold because these distorting taxes are distorting things. Just as in the Barrow model, there's going to be an exogenous government expenditures that has to be financed. So the government's going to have to select one of these equilibria with distorting taxes. Which one should it pick? So there's going to be distorting taxes and state contingent debt, but they're all going to kind of be bad relative to the Stalinist equilibria. The Stalinist solution, where you don't go through a competitive equilibrium, you just have a command economy. This isn't a command economy. It's a competitive equilibrium. So what the government's going to do, the Ramsey problem is pick the best competitive equilibrium. In other words, pick the best competitive equilibrium. That's it. So that optimization problem is easier said than done. And it's a problem. Actually, we don't still have a complete understanding of it because in terms of our methods, because lots of assumptions about convexity and concavity break down. And the way this has been solved in applications is people cross their fingers and hope that a certain method works. And I'm going to show you a little bit about that. Okay. So, so you could read the introduction to this. So it's again going to be classic issue about how to pay for a war in a closed economy, and so what a war means is a more or less temporary surge in exogenous government expenditures. So the government there's going to be exogenous stream of government expenditures, and we're going to make it Markov, or a function of a simple Markov state. And the government, there's going to be work. There's going to be no capital in this model. That was a shrewd choice because in later work, people like Char and Keogh showed that you could add capital and it doesn't add a lot to the insights that you get, but that's another story. What the government do is have a flat rate tax on labor. Why flat rate? Lucas and Stokey make that up. It's a flat rate tax on labor that can depend on the Markov state and the history of the Markov state. And it can depend on time if you want. So you can either do that or you can buy or sell Aero securities. And there's going to be a representative household that values consumption and leisure, be a very simple linear production function that maps labor into a single good. And there's a Ramsey planner who at time t equals 0, he chooses once and for all a plan for taxes and trades of Aero securities for all t, and then walks away. This is going to be under, that's what some people mean by commitment. It's going to, you can think of it as choosing, this is a static problem, chooses once and for all and walks away. So the way this lecture goes in quant econ is we're going to use this as a vehicle for both showing the Lucas-Stokey model, expositing how manipulation of prices is at the center of it, and then go on to, we'll solve it kind of in a space of sequences. It's kind of the way Lucas and Stokey did it. And then we'll come back and show that it can be solved with a version of dynamic programming squared by if we formulate things recursively. And again, that's where we're going to go.